So next we have Janice. So she's going to present on her journey through mathematics, and the time is yours, Janice.
Yeah, okay, thank you. I'm just gonna quickly share my slides. Can people see my slide? Okay, hopefully. Okay. So hi everyone. So before I get started, I just want to quickly introduce myself a little bit. So I'm a 10th grader at Branksome Hall, which is a school in Toronto. And last year I qualified for the USAJMO, and I was invited to participate in the Math Prize for Girls, which happened during October this year. And okay, what I want to talk about today can be divided into 4 sections, and I want to introduce some math competitions that I believe people should know, and then I want to talk about how to best prepare for them, and then I want to introduce some math programs and opportunities that if people are interested, then they could consider to apply for or to participate in. And then I want to bring focus to some math opportunities specific for girls. Okay, I believe last week or the week before, probably most of you have done the AMC 10 or the AMC 12, and which is basically the most important math competition, the American mathematics competition. And one thing to mention that for the if you do well in the AMC 10, AMC 12, you will be able to qualify for the AMY. And then after AMY, if you also do well in AMY, you will be able to qualify for the USAMO or the USAJMO. And basically, this is a whole pathway that one person will be able to get into the US National Training Program for the IMO and then get into the American Olympiad team. But I believe if most of us here are probably Canadians, and for Canadians, probably the top you could get would be to participate in the USAMO or the USAJMO. And then similar to the AMC, but like Canadian version of the AMC would be the COMC, which is the Canadian Open Mathematics Challenge. And that is like the first step to get you qualified for the Canadian National Olympiad team. And the thing that's different from AMC about COMC is that rather than being like multiple choice, it's a more like solution writing, full solution sort of contest. And if you do well in the COMC, you will be able to qualify for the repechage and then later to the CMO and then all the way to interchem and such. And that's about it for like qualifying for national teams for if you want to aim for the IMO. Then the other contest that's becoming more and more popular is the Waterloo Math Contest. And there are a bunch of them each year. And I would say generally, compared to the COMC and the AMC, the Waterloo contests are less difficult and less important because there are so many of them each year. But because the University of Waterloo has a very competitive and very popular computer science and math major, so if you are interested in those majors and want to apply for University of Waterloo, I would suggest that you show some achievement in their math contest, namely the Euclid, which is probably the hardest one among all the Waterloo math contests. And yeah, that's about it for like the individual contest. And now I want to introduce some like team competitions. The most prestigious one's probably the HMMT, which is held by Harvard and MIT. There are usually two different seasons, one happening in November and one happening in February. So the November one is usually a bit easier and has a difficulty around like mid-range AMC to all the way to upper AMY level. And it's usually like short answer and like more of those types, like the AMY type of question type. And then, however, for the February one, it's a lot more difficult and can be all the way up to the Olympiad level. And it involves more of like proofwriting and stuff like that is usually more associated with Olympia level math. And besides HMMT, there are some other team math competitions as well. The Berkeley Math Tournament, which happened a couple of weeks ago, it's held by the University of California, Berkeley. And I participated in that like a few weeks ago because they had a satellite location at UTS, meaning that like at UTS, which is the University of Toronto Schools, they also held like a section, like sort of like a subsection of the Berkeley Math Tournament. And Berkeley Math Tournament is pretty much like it could be a good representation of what generally team competitions would look like. So usually they will have a power round. So for power round, it's mostly like proof-based questions and like it's a team round and everybody just contribute to a whole set of like proof questions that involves like proof writings and stuff like that. And then for individual round, it is usually most team competitions also have an individual round and like people do like an individual task that of their choice. Sometimes it's more general, sometimes you can have more options that you want to do. And so they usually take the average of the individual round. And then there's usually the guts round or like probably like the short answer and more like a speed round. And for that, it's like everybody would try to like solve questions and there's usually like live scoreboard so people can see, so it's a little bit more intense. And then all three combined together, they would determine like which team would place. And that's about the same for like most of the team math competitions. And there are also some other ones besides the Berkeley one. There's the ARML, the American Regions Mathematics League, and also the PUMAC, which happens in Princeton each year. And for the latter two, I didn't really participate in any, so of any of those, so I don't have as much experience. And but I put the link for all of them like in the slides. So if later, I believe probably Stephen could share the slide with you guys. And then if you're interested to learn more about like registration and past contests and past problem sets and stuff like that, you can always just like click into the link and see more for yourself. And one of the main challenges for team competitions is that sometimes it's pretty hard to find teammates of similar interest and level. So I would say for this part, the Princeton one is pretty just pretty good because they welcome individual registration, meaning that you can register as an individual, and based on your level, they can probably put you in teams. And then that's the same case for the Berkeley Math Tournament, except that the Berkeley Math Tournament is a little bit smaller in scale, so that there's less of individual participants and individual registrations happening. Therefore, it's harder to be put into groups. But generally, if you're an individual who also want to participate in team competitions, there are still opportunities and ways for you to do so. So that's about it for like math competitions. And then I want to talk about how I think would be important to prepare for math competitions. And I think they generally can be divided into two steps. Step one being like the learning of like base knowledge, like the base theorems, concepts, and things you would need to use basically in math competitions. And I think the way a way you could do that and the best like materials to study would be the art of problem solving books, as many of you probably would have already heard of the art of problem solving website. It's a really great website. If you just search it up, there's a lot of like past AMC problems, a bunch of like different problem sets, a huge like problem bank. But besides that, they have really great books on like they basically can cover most of the competition stuff you need to succeed in most of the intermediate level competition, like the AME and the AMC and the CUMC. And So there's like specific ones for specific areas, like for example, they have books on combinatorics, they have books on like geometry and stuff. They also have the auto problem solving like volume 1 and 2, which are really great for like AMC and AMY. So if you want to like really study the basics of like where all the questions are like rooting from, then it's a great way to just study those books. And then the second very equally important step is by practicing, which is basically helping you to use the ideas and the theorems that you learned from the books. And so I would say for practicing, if you want to prepare for a particular contest, the best way to practice definitely going to be looking at their past problems. Like if you want to prepare for AMC, you can look at the past AMC problems and past Waterloo problems for Waterloo contest and stuff like that. And I would say usually if you encounter a problem and you are not able to solve it, the best way is to like after looking at a solution to really like think about or summarize how like in which step you probably got stuck and how later you can improve on it. And it's important to like go back to problems you didn't solve before and to see if you really grasp the concept after reading the solution. And besides just like going through problems quickly and like just reading solutions. So I think it would be a lot more beneficial if you could really like dig into the basics of understanding each problem and how to do them. So in the future, if you encounter similar types of problems, you'll be able to do them a lot more successfully. And by practicing, it really helps you like it really helps you know what ideas and what theorems would be useful in what kind of questions. And especially in some of the more like time consuming, more like for a tight time sort of contest like the AMC, you basically have to identify the right way to solve a problem pretty fast. So then it will be useful if you have more experience with problems, then you can handle those problems faster and more like accurately. And I think that's about it for like preparing for math competitions. And then I want to talk about some math programs and opportunities. Like for example, during the summer, sometimes during winter breaks and stuff like that. There's a huge list of mathematics summer program on the Art of Problem Solving website. And the link I've already put it here in the slide. And so if you want, you can like dig into those and look at the list of problems and like looking at their website and stuff. Then you can probably see which program are more of your interest. But what I want to do here is just to like sort of guide you with a brief introduction of the math programs and talk about like some of my personal experience with some of those that I attended. So I think math programs can also generally be divided into like two subcategories. The first one being more of like math contest prep / like training camp type. And for that, if you want to prepare for like math contests in a summer program, in a summer training camp, I would say Awesome Math is a pretty good option. I went there about 2 years ago and it was online because of COVID during that time. But what I really like about it is firstly, it really separate people up into like certain levels. So you can go to the level that will best suit your ability and help you grow. And so they have a wide range of level. It can be like introductory, intermediate level, all the way to like Olympiad level. So make sure like no matter where your level is, you can always benefit in that program. And usually what they do is they would talk about a particular topic or concept, and then they would have some like sample problems that you can do. And then there's usually like group problem solving sessions or like a lot of time for you to like solve problems with peers. So it would be a great way to like spend your summer if you want to like do some um preparation for math competitions and work out questions with like different people, and also meet people with like different with like similar interests in math. And they also have like instructors there, always there to like answer questions and to help you work through problems. There are actually many of programs similar to Awesome Math, and then you can find them in like the art of problem solving website, which I talked about earlier. But I would say this one is the one I personally had experience with, and I felt it was a great program. And then the second one, the second subcategory of camps are more um like broadly outside of the high school curriculum or contest sort of scheme. It's more like for undergraduate slash like research math programs. And one of the more prestigious ones would be like Ross and like Promise. And those math camps are really rigorous and really competitive. I would say for those, although it has like a less direct relationship with helping you prepare for math competitions, those are really great if you want to just really dig into math, especially a specific field that you're interested in, like number theory and stuff. And or if you really want to just explore like undergraduate like university math, and you would think that those would be of your interest and you want to explore more of those, it would be really beneficial for you to attend those kind of math camps. And for those math camps, from my experience, I would say what they really look for is they will usually have a problem set during the application, a problem set you probably would have never like seen before, because the problems are usually very unique and nothing that you would encounter in high school. And they will see how you do on the problem set that they give you, and then they really want to see your interest in really doing math, because those programs they usually do like at least I would say 10 hours of math every day for like up to 6 weeks. So that's a really long time. So they really want people to like math as a subject itself, and to really like this spending time just digging into math, and to think that you would be a good candidate for these type of math programs. And last summer I went to the Math League, which is relatively compared to like um some of the other ones a bit broader, because it doesn't really focus on particular topics or like an area of math. It just like sort of like a helping us discover like different topics of undergraduate maths. And I think it was really fun because I never encountered those topics in like high school math competitions and stuff like that. So it really helped me like broaden up like the knowledge around like math. So if you're interested in those, then there are also a number of opportunities for you to do so. And then that's about it for like just generally the competitions, the resources and opportunities and stuff like that. And then I just want to talk about some of the opportunities specific for girls, because you know, the gender disparity in like the STEM field is pretty significant. And that's why there's like more and more initiatives specifically for girls to help girls succeed in the STEM field. And so the first one being the European Girls Mathematics Olympia. This is basically the girls version of IMO, so it's very competitive, very difficult, and it's like the basically the most advanced math competitions. And like they have like Canadian, us Canadians probably they usually look at your CMO score. They usually look more at your like COMC score and how you do in COMC, but they also take into consideration of your like past AMC, AME scores, and it's a whole algorithm I would say. But as long as you like do well in the COMC, and CMO, you probably would have an opportunity to like to get their attention, and then they will have more like selection process and stuff like that. And then other programs and contests specifically for girls, the math prize for girls, which I talked about that I attended this October, it happens at MIT. It's a pretty huge like event because it's been happening for quite a bit of years, and they have a lot of like sponsorship and like funding toward this program, and it's also associated with MIT, which also just brings more points for the event itself. And its selection process is really simple. It only consider your AMC/AMY score, and usually people apply around June, and they just like submit their AMC score, and usually they will select the top 200 applicants and invite you to the Math Prize for Girls event happening that year. And the contest is usually held in October. There are huge prizes for the top performance, just so that the point is to get girls, to inspire girls and to motivate them to participate in the STEM field. And then I remember my experience was just before the contest, we had sort of like a activity night, and to get to know other girls who are interested in the STEM field. And then they would have just like a contest day that you just basically do like 20 questions in the morning, and then they will grade them. They're all like short answer questions, so they don't look at your steps, and then they would just award for the top performers. And one more bonus point for this event is that it can really help you if you're interested in MIT, or you want to get to know more about MIT. It's a great way to do so by participating in this event, because it's held in MIT, and they usually they usually offer you tours around MIT, and then they also give you admission sessions on like what MIT is looking for their undergrad, and then you can learn more about MIT admission. You can learn more about the school itself. So it's a great opportunity to apply for. And besides that, I would say there are more and more emerging like programs, initiatives, scholarships given by like universities and foundations to support girls specific in this area, in the STEM field. So if you're a girl and you are interested in the STEM field, I would say you can definitely look into those opportunities more, because there are a lot of universities that offer those, and it would be a great way to learn more about like people who also participate in math, and to learn more about like different schools, and there are many great opportunities to do so. So I would say that's about it for what I want to talk about today. So I just want to say, because I cover a lot of information, and probably there are also information I forgot to cover. So if you have any question and you think that I could help you with, feel free to like raise your hand, or like put it in the group chat. So I'll just wait a second to see if anybody has any questions.
Okay, great. Thank you, Janice, for sharing your experience and all the resources. So I don't see any questions from the audience. So let's call that the end of today's lectures. I would like to thank Janice and Alex for coming today to give us this lecture.
Thank you for the opportunity.
Yeah. Right. Great. So let's end that here. Okay. See you guys. Bye.